वेलकम बैक स्टूडेंट्स। आज जो हमारा टॉपिक चलने वाला है वो है मल्टीपल चॉइस सिंगल आंसर लिसनिंग का। ओके, हम पहुंच गए हैं डे 17 पे। हमारे टोटल 16 डेज खत्म हो गए हैं। उम्मीद है आपने अच्छी खासी अब तक रीडिंग की ब्लैंक्स सॉल्व कर दी होगी, समराइज स्पोकन टेक्स्ट भी सॉल्व किया होगा, फिलिंग द ब्लैंक लिसनिंग भी सॉल्व किया होगा। नहीं किया पॉज कर लो वीडियो, पहले वो सॉल्व करो। ओके, वो चीज़ें इंपॉर्टेंट है, ये इंपॉर्टेंट नहीं है कि ये वाला टॉपिक ज़रा अभी इम्पॉर्टेंट नहीं है। बस समझ लो ये टॉपिक में करना क्या होता है। जो हम मल्टीपल चॉइस सिंगल आंसर में करते थे रीडिंग पोर्शन में, वैसा ही एक है कि पैसेज आपको सुनाई देगा, आपको अब एक आंसर टिक करना है। ऑडियो आप स्किप नहीं कर सकते हो, सिर्फ लिसनिंग में कंट्रीब्यूट होगा। 1 या 2 मार्क का है, सही गया तो ठीक है, नहीं तो कोई बात नहीं। ऑडियो पे ध्यान देना है आपको क्लियरली। कि आपको ऑडियो पे ध्यान देना है क्लियरली। आपको एक ऑप्शन टिक करना है, एक ही टिक हो पाएगा क्योंकि सर्कल बना हुआ होगा। सर्कल यानी एक ही ऑप्शन टिक हो सकते हैं, नेगेटिव मार्किंग नहीं है। नेगेटिव मार्किंग सिर्फ मल्टीपल चॉइस क्वेश्चन में है और दूसरे क्वेश्चन में जो हम आगे जाके देखेंगे। ओके, तो सिर्फ मल्टीपल चॉइस वाले में नेगेटिव मार्किंग होता है, उसके अलावा और एक क्वेश्चन बस, उसके अलावा पूरे पीटी एग्जाम में कहीं नेगेटिव मार्किंग नहीं होता है। सो टॉकिंग अबाउट एमसीक्यू सिंगल, हमेशा एक तरीका याद रखना है इसके अंदर कि पहले है क्वेश्चन पढ़ लो। द वुमेन बिलीव दैट ई कॉमर्स इज गोइंग टू कंटिन्यू टू ग्रो बिकॉज, क्योंकि वो पूरा पैसेज बोलेगा। वो 35 सेकंड का भी हो सकता है, 55 सेकंड का भी हो सकता है, मैक्स 70 सेकंड। ओके, 1.5 मिनट तक का, ऑलमोस्ट 90 सेकंड मैक्स। चलो 90 सेकंड मैक्स गिन लेते हैं, उससे ज़्यादा वो ऑडियो नहीं होगा। ओके, उसमें ये लाइन है ना, कहीं वो बीच में बोलेगा। ओके, आपको स्पीकर वो लाइन कहीं बीच में बोलेगा तो आपको पूरा पैसेज समझने की जरूरत नहीं, पर वो लाइन की राह देख लीजिए कि वो लाइन कब आ रही है। ओके, वो लाइन आएगी, अगर वो लाइन बोल रही है या बोल रहा है तो वहाँ पे वो क्लियर आपको समझ में आएगा। इसलिए आपको कंसंट्रेशन इसमें ज़्यादा रखने का है। ये वाले पैसेज के लिए मैं एक लाइन प्ले करता हूँ। ओके, मैं ऑडियो प्ले करता हूँ तो आपको समझ में आ जाएगा कि इसका आंसर क्या है। नहीं समझ में आता है, कोई चिंता नहीं, कोई वेटेज नहीं है इस चीज़ का। पर आज का दिन है, आज के दिन के लिए इसे सॉल्व कर लो, क्योंकि ये फ्री के मार्क्स है। ओवरऑल में आपके 5 to 7 मार्क्स ये छोटी छोटी चीज़ें बढ़ा के दे सकती हैं। चलिए तो हम ऑडियो प्ले करते हैं।
Since the coronavirus pandemic hit the US, over 40 million of Americans have filed unemployment claims. But some benefited from the crisis. Already in mid-March, the largest online retailer, Amazon, announced its plans to hire an additional 100,000 people. A lot of other places are looking for delivery drivers, and grocery stores are in constant need of employees.
We have gone to a mode where we're all shopping online, we're buying online, and I think that's probably going to continue. I don't think people are going to be anxious to get out to the stores anytime soon, and they learn the convenience of it. So I think e-commerce is really going to continue to grow, and that means more jobs in that industry.
ऑडियो के एंड में एक वुमेन कुछ बोली, आपको ऑडियो का स्विच हुआ दिखा कि स्टार्टिंग में तो न्यूज़ था, पर एंड में कोई एक वुमेन ने अपना कोई पॉइंट ऑफ व्यू रखा। उस वुमेन, मैंने बोला था तो बीच में एक लाइन बोलेगी, तो वो लाइन में उसने क्लियर बोला है कि कंज्यूमर ने सीख लिया है कि ऑनलाइन कैसे शॉपिंग किया जाता है। इट इज़ ना, दे नाउ नो हाउ कन्वीनियंट इट इज़ टू शॉप ऑनलाइन। क्योंकि स्टार्टिंग में उसने समझा कि कोविड हो गया है, सामान नहीं आ पा रहा घर पे, या वो बाहर नहीं जा पा रहे, तो इसलिए लोग ऑनलाइन पे स्विच हो गए, ई कॉमर्स पे शिफ्ट हो गए हैं। तो उसने वो लाइन क्लियर बोली थी। तो आई थिंक द आंसर इज सी। अगर आपका ये आंसर, आपने भी ये आंसर सोचा था तो मुझे कमेंट में ज़रूर बताइएगा। आंसर इज सी। ओके, तो एमसीक्यू सिंगल की आगे प्रैक्टिस आने वाली है। आज के दिन के लिए एमसीक्यू सिंगल जितने हो सके प्रैक्टिस कर लो, एक बारी करके साइड में रखने, आज ही ख़त्म कर लो, क्यों कल पे छोड़ना। चलिए कल मिलते हैं।
Today we're going to discuss the environmental impacts of urban development. Urban areas, as we know, are expanding rapidly, leading to significant changes in land use. One of the most noticeable impacts is the loss of green spaces. This not only affects the aesthetic value of cities, but also has broader ecological consequences. For instance, the reduction in green spaces can lead to a decrease in biodiversity and disrupt local ecosystems. Another key concern is the increase in pollution levels, both air and noise pollution, which directly affects the health of urban residents. To mitigate these impacts, it's crucial for urban planners to incorporate sustainable practices in their designs, such as creating green belts and using eco-friendly materials.
In today's lecture, we'll explore the concept of renewable energy sources and their growing importance. Renewable energy derived from natural processes that are constantly replenished includes sources like solar, wind, and hydroelectric power. Unlike fossil fuels, these energy sources do not emit greenhouse gases, which makes them crucial in combating climate change. However, the transition to renewable energy is not without challenges. The primary hurdle is the initial cost and infrastructure needed for these technologies. Despite this, the long-term benefits, including sustainability and reduced environmental impact, make renewable energy a key component in our global energy strategy.
Today, we delve into the intricate world of quantum computing and its potential to revolutionize our technological landscape. Quantum computers operate on the principles of quantum mechanics, a fundamental theory in physics that explains the nature of energy and matter on the atomic and subatomic levels. Unlike classical computers that use bits as the basic unit of information, quantum computers use quantum bits, or qubits, which can exist in multiple states simultaneously. This allows quantum computers to process a vast number of calculations at once, offering unprecedented speed and power. However, the development of quantum computing faces significant challenges. Quantum states are extremely delicate, and maintaining them long enough to perform calculations requires incredibly precise control of the physical environment. This includes maintaining extremely low temperatures and protecting the system from any external interference. Additionally, the programming languages and algorithms for quantum computing are still in their nascent stages, requiring a new approach to software development. Despite these hurdles, the potential applications of quantum computing in fields like cryptography, material science, and complex system simulation are vast, making it a key area of research and development in the technological sphere.
Today we explore the fascinating world of deep-sea exploration and the mysteries of the ocean's abyss. The deep sea, defined as the part of the ocean beyond the continental shelf, remains one of the least explored areas on Earth, with depths reaching over 11,000 meters. This environment presents extreme conditions, such as high pressure, low temperatures, and complete darkness. These conditions have led to the evolution of unique life forms, many of which are yet to be discovered or fully understood. Deep-sea exploration is not only about discovering new species. It also provides insights into our planet's geological history, helps us understand oceanic currents and their impact on global climate, and has potential implications for the discovery of new resources.
In this comprehensive analysis, we'll delve into the evolution of cryptographic methods from ancient times to the modern era. Cryptography, the art of writing and solving codes, has been instrumental in secure communication throughout history. Ancient civilizations used basic transposition and substitution ciphers, which evolved into more complex systems in the medieval period. The Enigma machine in World War II marked a significant advancement, but also led to the development of computer-based decryption methods. Today, we stand at the cusp of quantum cryptography, which promises unbreakable codes due to the principles of quantum mechanics. This historical journey not only underscores the importance of cryptography in shaping world events, but also highlights the perpetual race between code makers and code breakers.
In this session, we will explore the intricate relationship between cultural anthropology and linguistic diversity. Cultural anthropology, a branch of anthropology focused on the study of human cultures, uses linguistic diversity as a key tool in understanding societal norms and practices. Languages, being deeply intertwined with culture, offer insights into social structures, belief systems, and historical transformations. For instance, the study of indigenous languages can reveal unique perspectives on environmental stewardship and community living. However, the rapid decline in linguistic diversity, with many languages facing extinction, poses a significant challenge to anthropologists, as each lost language represents a loss of unique cultural knowledge. This phenomenon underscores the urgency in preserving linguistic diversity as a means to maintain cultural heritage.
Let us now turn our attention to the complexities of Byzantine art and its influence on the development of Western art traditions. Byzantine art, originating from the Eastern Roman Empire, is renowned for its spiritual representation and the use of iconography. This art form played a pivotal role during the Middle Ages, particularly in the development of religious themes. The use of mosaics, characterized by intricate designs and vivid colors, was a hallmark of Byzantine art, influencing the artistic expressions in Renaissance Europe. Moreover, the stylistic features of Byzantine art, including the symbolic use of color and flat two-dimensional figures, can be seen as a distinct departure from the naturalism that characterized Greco-Roman art. This exploration of Byzantine art not only provides a window into the religious and cultural dynamics of the time, but also offers insights into the broader evolution of European art.
In this session, we will delve into the phenomenon of urbanization and its socio-economic impacts. Urbanization, the process of rural populations moving to urban areas, has been a global trend, especially pronounced in the 20th and 21st centuries. This shift has led to the growth of megacities, presenting both opportunities and challenges. Economically, urbanization can lead to increased productivity and innovation, but it also exacerbates income inequality and can lead to the marginalization of certain groups. Socially, while urban areas offer better access to services like education and healthcare, they also face issues like overcrowding and inadequate infrastructure. Understanding the multifaceted impacts of urbanization is crucial for policymakers to create sustainable and inclusive urban development strategies.
Our focus today is on the enigmatic world of dark matter and its role in astrophysics. Dark matter, a hypothetical form of matter that does not emit or interact with electromagnetic radiation, is believed to constitute about 85% of the matter in the universe. Resistance is inferred from gravitational effects on visible matter and the cosmic microwave background radiation. The study of dark matter is crucial for understanding the large-scale structure of the universe and the dynamics of galaxies. Despite its significance in astrophysics, dark matter remains elusive, with scientists striving to detect its particles through advanced detectors and experiments. This ongoing research into dark matter challenges our understanding of the fundamental composition of the universe and raises profound questions about the nature of matter and energy.
Today, we explore the intricate dynamics of international trade and its influence on global economies. International trade, the exchange of goods and services across international borders, has been a driving force of economic globalization. It fosters economic interdependence among nations, promoting efficiency and innovation through competitive markets. However, this interplay also leads to complex challenges such as trade imbalances, impacts on domestic industries, and debates over fair trade practices. Additionally, the role of international organizations in regulating and facilitating trade is a critical aspect of the global economic landscape. Understanding these dynamics is vital to comprehend how global economies navigate the delicate balance between cooperation and competition in an increasingly interconnected world.
In this session, we'll examine the fundamental principles of behavioral economics and its deviation from classical economic theories. Behavioral economics integrates insights from psychology to understand how people actually behave in economic contexts, contrasting with the assumption of rational decision-making in classical economics. This field explores concepts like bounded rationality, where decision-making is limited by the information available and cognitive biases. It also investigates phenomena such as loss aversion, where individuals' decisions are disproportionately influenced by the fear of losses rather than the potential for gains. These insights challenge traditional economic models, suggesting that factors like emotions, social norms, and cognitive limitations significantly impact economic behavior.
Let's talk about the complex world of genetic engineering and its ethical implications. Genetic engineering, the direct manipulation of an organism's genome using biotechnology, has the potential to radically alter the fields of medicine, agriculture, and environmental science. In medicine, it offers prospects for treating genetic disorders and diseases. In agriculture, it enables the development of crops with enhanced nutritional value or resistance to pests. However, this power raises significant ethical concerns. These include the potential for unintended ecological consequences, the moral considerations of altering human-animal genomes, and the societal implications of creating designer traits. We advance in this field, the balance between the potential benefits and ethical considerations becomes increasingly crucial.
The topic on hand is the phenomenon of cultural globalization and its impact on local cultures. Cultural globalization refers to the transmission of ideas, meanings, and values across national borders, leading to a more interconnected and homogeneous global culture. This process is facilitated by modern communication technologies and media, which allow for the rapid spread of cultural products and practices. While cultural globalization fosters understanding and integration among different societies, it also poses threats to local cultural identities. There is a concern that this global cultural homogenization could lead to the erosion of distinct cultural practices, languages, and traditions. The challenge lies in finding a balance between embracing global cultural influences and preserving the uniqueness of local cultures.
In this discussion, we will explore the critical role of freshwater ecosystems in environmental sustainability. Freshwater ecosystems comprising rivers, lakes, wetlands, and aquifers are vital for the biodiversity they support and the services they provide. These include water purification, flood control, and habitats for numerous species. However, these ecosystems are under threat from pollution, over-extraction of water, and habitat destruction. The loss of freshwater biodiversity has far-reaching implications for global ecosystems and human well-being. Understanding and protecting these ecosystems is essential for maintaining the ecological balance and ensuring sustainable water resources for future generations.
Today's lecture focuses on the intriguing concept of time dilation in the theory of relativity. Time dilation, a phenomenon predicted by Albert Einstein's theory of relativity, suggests that time passes at different rates depending on the relative speed of an observer and the observed. According to this theory, as one approaches the speed of light, time appears to slow down significantly. This concept has profound implications for our understanding of the universe and has been experimentally confirmed through observations of particles moving at high velocities and experiments with precise atomic clocks. Time dilation challenges our conventional notions of time as a constant and uniform entity, opening up fascinating possibilities in the realms of space travel and cosmology.
In this session, we will examine the history and significance of the Silk Road in shaping global trade and cultural exchange. Silk Road, a network of ancient trade routes connecting East Asia to the Mediterranean, facilitated not only the exchange of goods like silk, spices, and precious metals, but also enabled a significant cultural, religious, and technological interchange between diverse civilizations. The Silk Road served as a melting pot of ideas, leading to the spread of inventions such as papermaking and gunpowder, and fostering the growth of major world religions. This historical analysis highlights the Silk Road's role in shaping the early globalized world and underscores the interconnectivity of human societies throughout history.
Our discussion today will centre around the phenomenon of supernovae and their role in the universe. A supernova is a powerful and luminous stellar explosion that occurs at the end of a star's life cycle. These cosmic events play a critical role in the evolution of galaxies, as they are responsible for the synthesis of heavy elements which are then dispersed into space. This process of nuclear synthesis is essential for the formation of new stars and planets. Supernovae also contribute to the understanding of cosmic distances, as their predictable brightness allows astronomers to gauge the scale of the universe. The study of supernovae, therefore, provides key insights into stellar evolution, the chemical composition of the universe, and the mechanisms of galactic formation.
Today, we'll delve into the complexities of the human microbiome and its impact on health and disease. The human microbiome refers to the trillions of microorganisms residing in and on the human body, including bacteria, viruses, and fungi. Recent research has revealed that these microbial communities play crucial roles in regulating various body functions, including digestion, immune response, and even mental health. The dysbiosis, or the imbalance of these microbial populations, has been linked to numerous health conditions, ranging from inflammatory bowel disease to mental health disorders. Understanding the human microbiome is not only pivotal for developing novel therapeutic approaches, but also offers insights into the intricate interactions between humans and their microscopic inhabitants.
Now let's explore the revolutionary field of nanotechnology and its applications in various industries. Nanotechnology, the manipulation of matter on an atomic or molecular scale, offers unprecedented control over material properties, enabling innovations across a broad spectrum of fields. In medicine, it promises targeted drug delivery systems and advanced diagnostic tools. In energy, nanotechnology is key to developing more efficient solar cells and energy storage systems. However, alongside these possibilities, nanotechnology poses unique environmental and health challenges. Due to the unknown impacts of nanoparticles on human health and ecosystems, as we harness the potential of nanotechnology, it is imperative to balance innovation with responsible development and thorough risk assessment.
In today's lecture, we'll explore the fascinating subject of gravitational waves and their significance in astrophysics. Gravitational waves, first predicted by Einstein's theory of general relativity, are ripples in the fabric of space-time caused by some of the most violent and energetic processes in the universe. The detection of these waves, a century after their prediction, has opened a new window for astronomical observation, allowing us to observe cosmic events like black hole collisions and neutron star mergers. This breakthrough not only confirms a fundamental prediction of general relativity, but also enhances our understanding of the universe by providing insights into phenomena that are invisible in traditional electromagnetic observations.
This session is devoted to the study of exoplanets and the search for extraterrestrial life. Exoplanets, planets that orbit stars outside our solar system, have been the subject of intense study since the first confirmed detection in the 1990s. With advancements in telescope technology, we have discovered a diverse range of exoplanets, some of which reside in the habitable zone of their stars, where conditions might be right for life as we know it. The study of these distant worlds not only expands our understanding of planetary systems, but also raises profound questions about the possibility and nature of life beyond Earth. The ongoing search for biosignatures, or indicators of life, on these planets remains one of the most captivating areas in modern astronomy.
Today, we will discuss the intricate world of quantum entanglement and its implications in quantum physics. Quantum entanglement is a phenomenon where particles become interconnected in such a way that the state of one particle instantly influences the state of another regardless of the distance separating them. This concept challenges our traditional notions of space and causality and has been a subject of philosophical debate since its inception. Quantum entanglement not only questions the limits of classical physics, but also has practical applications in quantum computing and quantum cryptography, potentially leading to new technologies with far-reaching implications in information security and computation.
In this lecture, we'll examine the historical development of the periodic table and its impact on the field of chemistry. The periodic table, first devised by Dmitry Mendeleev in the 19th century, categorizes elements based on their atomic number and chemical properties. This organization has not only provided a systematic framework for understanding chemical behavior, but also predicted the existence of elements before their discovery. A periodic table's evolution over time. With the addition of newly discovered elements and the refinement of atomic theories, reflects the growing knowledge in the field of chemistry. It is a fundamental tool in the study of matter and plays a crucial role in the advancements of both theoretical and applied chemistry.
Our discussion today centers on the advancements and challenges in renewable energy technology. Renewable energy derived from natural resources like sunlight, wind, and water is crucial for sustainable development and reducing our dependence on fossil fuels. Recent technological advancements have significantly improved the efficiency and reduced the cost of renewable energy sources, making them more competitive with traditional energy forms. However, challenges remain in terms of storage grid integration and meeting the energy demands of a growing global population. Additionally, the geopolitical implications of shifting from fossil fuels to renewable energy sources present complex challenges that need to be navigated carefully. The future of energy is inextricably linked to these developments in renewable technology and their successful integration into our energy systems.
Today, we will delve into the concept of black holes and their paradoxes in modern astrophysics. Black holes, regions in space where the gravitational pull is so strong that nothing, not even light, can escape, pose significant challenges to our understanding of physics. The concept of the event horizon, the point of no return around a black hole, and the singularity, the center where density becomes infinite, are at the heart of these challenges.
One of the most intriguing paradoxes involves the loss of information. When matter falls into a black hole, does the information it carries disappear forever, defying the laws of quantum mechanics? This question has led to the formulation of various theories, including Hawking radiation, which suggests that black holes may emit particles, potentially resolving the paradox of information loss.
Now let's move on and discuss about the principles of sustainable urban development and its importance in contemporary city planning. Sustainable urban development involves designing cities in ways that balance economic, social, and environmental needs. This includes promoting green spaces, efficient public transportation, and sustainable housing. One major challenge is urban sprawl, which leads to increased pollution, resource consumption, and social inequality. Another aspect is the need for resilience against climate change impacts, such as rising sea levels and extreme weather events. Integrating sustainability into urban planning not only improves the quality of life for residents, but also contributes to the broader goal of environmental preservation.
In this part, we will explore the field of neurology and the complexities of brain disorders. Neurology, the branch of medicine dealing with disorders of the nervous system, faces the challenge of diagnosing and treating conditions that affect the brain, spinal cord, and nerves. These disorders range from common conditions like migraines and epilepsy to more complex diseases like Alzheimer's and Parkinson's. The brain's intricate structure and the complexity of neural networks make understanding these disorders particularly challenging. Recent advances in neuroimaging and molecular biology are providing new insights into these conditions, leading to improved treatments and a better understanding of brain function and dysfunction.
Now, we'll discuss the critical role of biodiversity in ecosystem health and sustainability. Biodiversity, the variety of life in all its forms, levels, and combinations, is essential for the stability and resilience of ecosystems. Diverse ecosystems are better equipped to withstand environmental changes and provide a range of services, from pollination and water purification to carbon sequestration. However, biodiversity is under threat from human activities like deforestation, pollution, and climate change, leading to species extinction and habitat loss. The preservation of biodiversity is not only crucial for maintaining ecosystem health, but also for the overall well-being of the planet, including human societies.
Today, we're going to explore the historical development of democracy and its evolution in various societies. Democracy, a form of government where power is vested in the people, has undergone significant changes since its inception in ancient Greece. The concept of democracy has evolved from direct democracy in small city-states to representative democracy in modern nation-states. This evolution has been influenced by various factors, including cultural, social, and technological developments. Contemporary challenges to democracy include issues of governance, the impact of globalization, and the role of technology in political participation. The study of democracy's evolution provides insights into the changing nature of political power and the ongoing struggle for representation and freedom.
In this session, we'll explore the fascinating world of string theory and its implications in theoretical physics. String theory, a theoretical framework in which the point-like particles of particle physics are replaced by one-dimensional objects called strings, proposes a unified description of gravity and quantum mechanics. This theory suggests that the fundamental constituents of the universe are not zero-dimensional particles, but rather tiny, vibrating strings. String theory has led to the concept of multiple dimensions beyond the familiar three spatial dimensions and time. These extra dimensions could be compactified or curled up in such a way that they are imperceptible at human scales. Despite its elegance and potential to unify the forces of nature, string theory remains a highly speculative and mathematically complex area of physics, with significant challenges in terms of experimental verification.